Welcome. I am Megan Riley Caton of Oceans 2050, where I lead a project focused on creating a new voluntary carbon market for seaweed farming. I'm the moderator today for the excellent lineup of speakers and panelists talking about carbon capture and removal from the perspective of nature-based solutions. We have with us today experts in carbon removal in soil and oceans, one of the world's leading climate scientists and fantastic entrepreneurs, and I know it will be a great discussion. First, we will have a keynote talk from Brad Ack. Brad's conservation career has spanned 30 years in ecosystems from tropical forests, high deserts, and temperate rainforests to the global ocean. Brad has worked for both government and NGOs at senior levels, at the interface of science, policy, and economics, designing innovative approaches to complex environmental challenges. His extensive experience in the ocean space includes running the Oceans Program at World Wildlife Fund US and serving as head of the Americas for the Marine Stewardship Council. Brad currently serves as Executive Director and Chief Innovation Officer for Ocean Visions. Brad is on a mission to bring the oceans and the climate communities together. No small feat, and to identify and scale up quickly climate change mitigation solutions for the oceans. He has been a source of enlightenment and inspiration to me personally in my work at Oceans 2050, and I'm delighted to pass it over to Brad to share his compelling message with all of you.
Thank you, Megan. That was a lovely introduction, and good morning to you. Good afternoon to everybody. It's really a pleasure to be here. The title of my talk, which hopefully the slides will be appearing on the screen shortly, is Reversing Climate Disruption and Ocean Decline. And I want to just dwell on the fact that these two things are intimately linked. You cannot heal the oceans without healing the climate, and we can't stop climate disruption without addressing the problem in the ocean. And fortunately, the second part of the title, using the oceans to, the power of the oceans to remove carbon. So I'm using a clicker that I've just clicked. Let's see if it works here to go to the next slide. Yes. So we start with the premise that the climate emergency is right now. It's not something that we're waiting for to happen 20, 30 years from now. The evidence mounts around us every day. I read yesterday about zombie fires above the Arctic Circle that are burning year-round in the peat. Basically, you can't look at the paper and not see evidence of this emergency that's all around us. And what many people don't realize is that, in fact, the oceans have suffered disproportionately so far from the climate emergency. We don't call it suffering. We often say the oceans have shielded humanity, or they've absorbed much of the heat. But in fact, this has come at a great cost. Here's just a couple of small examples: the enormous and increasing in frequency bleaching on the Great Barrier Reef and pretty much every other coral, warm water corals in the world, and calving of large icebergs off of Antarctica and the melting of the Greenland ice sheet. So what we don't focus on sometimes, perhaps enough, is that there are two major causes of harm to the ocean that are both driven by too much carbon in the atmosphere. The first is thermal stress. Thermal stress, as you can see from the graphic on the screen, is basically the heating of the ocean. The oceans have absorbed an unfathomable amount of heat since we started pouring carbon dioxide into the atmosphere. It's calculated to be heating at a rate of about 5 Hiroshima bomb equivalents of heat into the ocean, 5 Hiroshima bomb sized heat equivalents into the ocean every second of every minute of every hour of every day. That's how much heat we're pouring into the ocean. And of course, that is having a big impact. First, you've got sea level rise accelerating as a result of this. Intensifying marine heat waves. I mentioned the loss of coral reefs. A warmer ocean creates much more powerful storms as much more moisture comes up into the lower atmosphere. We've got this increased melting of sea ice, which actually affects the ocean environment in many ways. Deoxygenation, warmer water doesn't hold oxygen as well in the upper layers, and so we have visible signs of stress for marine organisms. we see actual changes in currents, and the one spot on this map in blue is actually melt of water off of Greenland, which is affecting the Atlantic overturning circulation, which actually controls weather in Europe. So this is something of grave concern. We see interrupted mixing in the layers of the ocean, and in fact, poleward migration of marine animals away from warming waters in the tropics. So this is a slow moving natural disaster in the ocean, all caused by one thing: too much carbon in the atmosphere. And secondly, too much carbon in the ocean, because about 30% of all that CO2 is going directly into seawater, which is leading to ocean acidification. This is direct absorption of carbon dioxide into the water in very large scales. And you can see the red upward line is CO2 concentrations in the air, and the blue is the reduced pH of the ocean, which is leading to more acidity. Now, this affects the production of aquatic life. Any aquatic life that forms a shell is affected by this. So again, another slow-moving natural disaster with a host of unknowns. And I will just repeat, thermal stress and chemical stress, there's only one way that we turn these off in the oceans, and that is reducing overall concentrations of atmospheric CO2 and oceanic CO2. Both are important. If you just take it out of the atmosphere, the oceans will respire CO2 back into the atmosphere because they live in dynamic equilibrium. So we have to tackle both. And sadly, current action and policy to do this are wholly inadequate. And we all know this. That's why we're here. That's why we get up every day and work on these issues. But the graphic on the left is basically a plot of international climate agreements, including obviously the Paris Agreement in 2016, with basically against rising emissions. So these agreements have done nothing to slow down emissions. In fact, they've intensified. The graphic on the right is from the statistical review of world energy put out by none other than BP, and it shows greenhouse gas emissions continuing to rise, investments in fossil fuels continuing to rise, and an enormous dependence on fossil energy. And an average annual growth in CO2 emissions over the last few years greater than the 10-year average. So our current climate plan is failing. Secondly, we're aimed at a target that I would argue is dangerously unsafe, this 1.5 target. And I know people say that it's science. It's actually political science. It's not science. Scientists will tell you, as you can see in the graphic on the right, that we're already at unsafe global temperature increases, and that as we inch up, it gets more and more unsafe. So 1.5 is just less dangerous than 2, but it is still dangerous. And it's also obviously very dangerous for the oceans. And you'll see, if you can read the slide, some of the things across the bottom, like warm water corals, are already in the red at 1 degree. So the other part about the 1.5 target is we have this really unfortunate thing called feedback loops. They're perversely called positive feedback loops, but they're anything but positive. These are parts of the global system that, as they warm, actually contribute more to climate warming. So things like the loss of Arctic ice, which allows more absorption of heat into the Arctic Ocean rather than reflecting it into the atmosphere, which is actually responsible for about 30% of all the global heating so far. Also, the thawing or melting of the permafrost, which has the possibility of releasing very large amounts of methane and CO2. So as temperatures go up, these feedback loops start to contribute more to the problem, and they make the hill that we have to climb even bigger. And the 1.5 degree impacts on the oceans are potentially going to create irreversible change. So we need a new climate plan. We need a new climate plan for the ocean. We need a new climate plan for humanity. Currently, most of our focus is on number 1 in this graphic, which is decarbonizing. That's cutting the future emissions of carbon. absolutely important. We have to do it. We've been working on it for 45 years, haven't made a huge dent. We're poised to make rapid change, but at this point, we're too late to be able to rely just on that tool alone. So now we need to add what are called negative emissions, which is really just nothing more than the cleanup of legacy CO2 pollution. And then there's a third component I'm not going to get into today, which is ecosystem life support, which is we have to slow down those tipping points. But let's just talk about the first two for the moment. So decarbonization, I've already mentioned, is going to require unprecedented transformations. These are words from the IPCC report on a 1.5 target. They require rapid and far-reaching transitions. The International Energy Agency had a report just this week that said we'd need to essentially start shutting down all coal-fired power plants and not building any new ones right away to achieve this target. And that's clearly not happening. So that's where we need to move to Plan B, adding it to Plan A, which is cleaning up this legacy of pollution. And I would posit that this legacy of pollution is like a Superfund site, which is a U.S. program to clean up long-lived toxins that have accumulated in the biosphere. Again, from the 1.5 report of the IPCC, they have shown that all pathways that will limit global warming to 1.5 require removing very large amounts of carbon, in addition to reducing emissions. Going beyond a 1.5 target will require even more. Now, here's where we get to the carbon, the role of the ocean in carbon capture and storage. The ocean already cycles enormous quantities of carbon, and it has the capacity to do more, basically by employing biomimicry and geomimicry, essentially accelerating, accentuating, and emphasizing some of the things the ocean already does. There are a number of different ocean-based pathways, from what we call biotic, which are plant-based, either macroalgae or microalgae, to abiotic, which are things that are more industrial, like dissolving alkaline or silicate materials into the oceans. We at Ocean Visions have been working on a series of roadmaps, technology roadmaps for ocean-based carbon dioxide removal, because basically this area has remained very underinvested as a pathway for carbon removal relative to terrestrial approaches like planting trees or biochar or BECCS, bioenergy with carbon capture and storage. And so to address this sort of lack of investment and lack of awareness, we've convened experts over the past year from across the globe to really understand what are the ocean-based carbon dioxide removal technologies that are available, what are the current states of technological readiness, and what is needed in order to move these fields forward. We looked at three big domains that you see there in the middle of the screen: macroalgae cultivation and sequestration, so that's seaweed; ocean alkalinity enhancement, which is putting alkaline material into the water in order to interact with CO2 in the seawater and actually remove CO2 from the atmosphere. And then electrochemical approaches, which is using electricity, needs to be renewable, to separate carbon dioxide, carbon ions out of seawater. We also looked at two additional cross-cutting themes: growing and maintaining public support, because we greatly lack public awareness and support for the importance of this area, and expanding finance and investment. You can see these maps at oceanvisions.org. This is what they look like. They're designed to be very interactive. So when you click on one, right now only macroalgae is up. You will see this graphic, which shows you basically the technological readiness, the obstacles, the development needs, and in that lower left corner, what we call the first order priorities. And these are the things that we are galvanizing effort and attention around. And so this is just a click into the first order priorities. These are actually renamed. They're more specific now, but basically we are working to get more an array of controlled field trials across the globe on growing and sinking seaweed. We're working to build and maintain public support, and we're working really hard to unlock more investment. So I would encourage you to visit this. And also there's going to be, as we add functionality here in the next days and weeks, a way to actually become an authorized user, to be part of a community that is working on key pieces of these roadmaps. And so we're really excited about this product. We're really excited about the possibilities and potential for ocean-based carbon dioxide removal. And I'll just leave you with a couple of thoughts. We cannot solve the climate crisis without addressing the crisis in the ocean, and we cannot solve the ocean crisis without addressing the climate crisis. Cleaning up carbon dioxide removal has to become part of the agenda, and we have to expand greatly our attention to cleaning up carbon dioxide removal, and the oceans can play an enormous role in all of this. So thank you for your attention. Thank you for joining today. Please reach out to me through the platform, and I'd be happy to talk to any of you. Back to you, Megan.